I'm picking up with number 7. The table shows the chemical formulas for 4 substances. Which substances have the same number of carbon atoms? Okay, this one has 2. This one has 8, because the subscript here is 2, the subscript here is 8. The subscript, ooh, tricky. There's 1 carbon here, because there's a subscript of 1 that's not written. There's 1 carbon here, subscript of 1 that's not written. That's a total of 2. And then here, there are 4 carbons. So which substances have the same number of carbon atoms? Substance 1 and substance 3. Let's see. Substances 1 and 3. There you go. The chemical formula for acetone is shown below. How many atoms of carbon are in 1 molecule of acetone? Again, be careful here because carbon is located in 2 different places. Here is a carbon. Inside the parentheses, the subscript is 1. 1 times 2, so that's 2 from over here, but then there's 1 more right here. So that is a total of 3 carbons in 1 molecule of acetone. And I know that there's only 1 molecule of acetone because there's no coefficient over here in front. Okay. Number 9. The table below lists several chemical and physical changes. Move the correct. Okay, so you're going to have to write it in because this is a paper copy. Scissors cutting a piece of paper. That is physical. It's still paper. Natural gas burning. That's one of our verbs that indicates a chemical change. You can't unburn natural gas. Water condensing. It just goes from water vapor to liquid water. So it's still water. It's a physical change. Filling a balloon with air. That's just physical change. You're just taking the air that was outside the balloon and putting it inside the balloon. Corroding metal. Corrode. That's another verb that indicates a chemical change. You can't uncorrode metal. You can sand the corrosion off, but you can't uncorrode it. An enzyme breaking down food in the mouth. Enzymes are things that speed up chemical reactions, so that's a chemical change. All right, number 10, how does a physical change differ from a chemical change? Well, the big thing with a physical change, it's still the same substance. You might have cut it into pieces. You might have changed it from a liquid to a gas or whatever. But like if you start off with water and you physically change it, it's still water at the end. Like you can melt ice, but both are water. Chemical change, new substances with completely different properties are formed. Okay, so let's see what choices are the best. Physical changes form new substances. Nope. Physical changes form a new substance with nope. Well, okay, let's go back to A. Form new substances with the same property. I don't know. Do they mean like solid water in the form of ice to liquid water? I don't know. Let's go back to that one. Physical changes alter the properties, changing the identity of the substance. Nope. If it's water, it was still water. Physical changes alter the properties without changing the identity of the substance. Okay, alter the properties. That kind of indicates chemical change. So even though I originally glossed over it, I think A is your best choice. Physical changes form new substances with the same properties. Chemical changes. I don't love this question. B and C are definitely out. A and D are what we're down to. Chemical changes form new substances with different properties. Chemical changes form new substances with different properties of matter. Physical changes form new substances with the same properties. I don't like new substances having the same property. That's a little bit sketchy. Physical changes alter the properties without changing the identity of the substance. Like, I don't know. Are they talking about, well, like water's density can change if it goes from liquid to gas. So I guess in the end, D is probably the best. But again, I don't love this question. What I need you to know is that physical changes, it's still the same substance. Like, it's still the same chemical formula, in other words. If something undergoes a chemical change, then you get completely new substances with new chemical formulas and different properties. So I don't love 10, but I think we're going to go with D on 10. Okay, our next question is number 11. The chart shows properties of 4 elements. Element 1, 2, 3, 4. Luster, shiny or dull, conducts electricity, conducts heat, melting point. Okay. Usually if it's shiny and conducts electricity and conducts heat, that's probably a metal you're looking at. Dull and doesn't, it's probably a nonmetal. Probably a metal. Dull, yes, yes, high. Might be a metalloid, who knows? Based on these properties, which element is most likely a nonmetal? Okay, so it's pretty easy to figure out which one's the nonmetal because a nonmetal is not going to conduct electricity. It's not going to conduct heat, like heat's not going to pass through it easily. And it's going to have a relatively low melting point. So we probably need to pick element number 2. And that's going to be letter B. Pretty easy. Okay, final question, number 12. Let's see. Blank are metals, blank are nonmetals, and blank are metalloids. Okay, so it's very hard to see, but let me pull this up in color. Okay, so it's pretty much impossible to figure it out on a black and white copy. So the blue are your metals, so that's A. All right, so I'm going to put A are the metals. These guys right along the stair step, those are going to be your metalloids. So that's going to be down here at the bottom. And then all of the bright green, those are your nonmetals. So they go metals, that's A because that's blue. Nonmetals, C because that's green. And B is metalloids because that's kind of orange. Okay, so one more time. A, B are your metalloids, and C are your nonmetals. So nonmetals, C, metalloids, B, and that should do it.